Out of the Fiery Furnace is brought to you by a company that makes aluminum for transportation, construction, and manufacturers of consumer products all around your house. Commonwealth Aluminum.
The stark, uncluttered landscape of the desert, free from distraction, is the place to appreciate two things which man placed in harness. Together they would yield one of his greatest achievements. They were the sun, warming the earth with the energy upon which all life depends, and the rocks of which the planet is made. Some 10,000 years ago, mankind first contrived to apply the energy of heat to the elements of the earth we know as metals, locked up, invisible, in the rocks. That discovery changed the landscape of history. It has molded the human career. It began man's long and revolutionary apprenticeship to the fire, furnace, and forge, which has placed metals at the foundation of our present material society. In our own astonishing time, man has landed on the moon, and there we have seen him conform to that ancient reflex. The first thing he did was to pick up and study the rocks. That view from space and the huge range of fresh archaeological discovery is peeling away history's old horizons. From new vantage points, it's possible to consider the civilizations created by man through a wider lens. A salient feature emerges from the heat and fumes and dust of 10,000 years of mining and metallurgy. It is that ever since metals began to make their volatile contribution to the flux of human affairs, they have been a cause and consequence of our material life. They've been determinants of success or failure among nations and states. And those who've had command of metals have been the masters of their age. By prizing open the doors to the vast treasure house in the rocks, man began to shake off one of his most remorseless constraints, his daily struggle for mere subsistence. He crossed a great divide from the Stone Age into the Age of Bronze. The transition from the Stone Age into the Age of Metals took place quite late in human history. In some parts of the world, a Neolithic culture has persisted even into recent times. A pre-metal society still lingers on in the desert of Central Australia. This aboriginal quarry is carpeted with flint chippings from thousands of years of tool making. Although the first Australians occupied a continent rich in minerals of all kinds, they made no practical use of any of these ores in their metallic form. Like early peoples elsewhere, they satisfied all their material needs with what was readily to hand. In Australia, alone of the inhabited continents, the special properties of mineral ores went unrecognized. Elsewhere, the discovery of metals seems to be associated with the changes in human society which took place in many parts of the world some 10 to 12,000 years ago, at the end of the last great ice age. The most significant of those changes was from the nomadic life of hunting and food gathering to settlement in communities. The corollary of settlement was the domestication of animals and the cultivation of crops. Above all, these advances meant that there was now time. Time for more than simple survival, time to think. That was the springboard for nearly all human progress towards modern civilization. The transition did not take place in all parts of the world at the same time. One of the first areas where man began to settle down in an orderly, less haphazard way was the Middle East, the lands that link the continents, Africa, Europe, and Asia. Discoveries in the last 20 years on the great Anatolian plateau of Turkey have provided the most revealing insight so far into those first habitations of civilized man. In archaeology, as in other forms of history, it's right to be wary of claims to uniqueness or primacy. But this vast mound in Anatolia is now considered to conceal the earliest town in human history, inhabited 8,500 years ago. Excavations have uncovered 12 successive levels of building over nearly 1,000 years, from 6,500 BC to 5,500 BC. The finds here provide a picture of a highly developed society without parallel in the Neolithic world, and one which for the first time appears familiar with metals. These archaeological discoveries of copper ores, together with natural copper, corroded green, are a beginning. More emphatic evidence of developing metallurgical skills is this copper mace head found near Çatalhöyük, dated to about 5,000 BC. It is the earliest known example of metal cast in molds. These displays in the Museum of Anatolian Civilizations in Ankara piece together life as it must have been lived in Çatalhöyük, which was bigger than Jericho and is the oldest town in the world of any size which is known to us. They show, too, that by the 6th millennium BC, Neolithic people had come to invest a particular curiosity in certain rarities to be found lying on the Earth's surface among the stones and rocks. And these things, unlike the stones, did not crack or chip when they were struck, but could even be hammered into various shapes. They were the first metals to be used by men, the so-called native metals occurring in nature in their pure state. And the most obvious ones to Neolithic men were, as they would be to us today, copper, like this piece of native copper, which was formed in its molten state in a fissure in the rock. Alluvial gold, and iron which fell from the sky as meteorites. The oldest metal objects worked by human beings all came from that particular group. But the supply of native metals, lying about easily to hand on the ground, because it was both rare and occurred in isolation, was a supply which was soon exhausted. But the aroused human intellect, of course, was not, and it contemplated the next step. It was a step which called for a huge leap of imagination, the discovery of how to smelt metals out of the rocks. That advance, made long before there was any understanding of either physics or chemistry or the elements, is one of the most far-reaching achievements in all human history. The blue-green ore of malachite gives no hint of the red metal which is locked up within it and linked by strong chemical bonds to oxygen. To separate or reduce the copper metal from this piece of malachite, two conditions have to be met. One is lots of energy in the form of intense heat, more than 1,000 degrees Celsius in the case of copper. And the other condition for smelting copper from the ore is an absence of oxygen, what's called a reducing atmosphere. Such an atmosphere draws off the oxygen from the heated oxide ore and reduces the metal within it to its pure state. It's a very exacting process, and it's hard to believe that Neolithic man at first set out deliberately to contrive it. It's more likely, surely, to have been the result of an accident, and in some situation in the ancient world where suitable metallic ores might well perhaps have been subjected haphazardly to the two necessary conditions. One, intense heat, and the other, the absence of oxygen in a reducing atmosphere. One very plausible suspect is obviously the campfire. It's often been suggested that early man must have, albeit unknowingly, built his campfires on metal-bearing outcrops or used lumps of metallic ores to make a fireplace. And next morning might have found unexplained blobs of metal among the ashes. The campfire theory still has supporters, but archaeometallurgists look elsewhere. For one thing, the temperatures reached in an open campfire are not very high, rarely more than 600 or 700 degrees Celsius. And the combustion gases create only an intermittent, reducing atmosphere above the coals. And so it seems highly unlikely that copper or iron, the first metals to have widespread use, could ever have been smelted, accidentally or otherwise, in an open campfire. But the conditions necessary for smelting did exist in one of the first technologies to emerge in Neolithic society. For thousands of years previously, there had been containers of wood, bark, leather, even stone. But no material could be worked and shaped with the ease and versatility of clay. Pottery no doubt had its origins in the observation that wet clay dries hard in the sun. The natural progression was to accelerate that drying process by heating the pots in fire. Some 9,000 or 10,000 years ago, it was understood by man that when clay was fired to a high heat, about 700 degrees Celsius, it changed irreversibly. The resulting crystalline structure was hard and waterproof. Pots have survived for thousands of years. The search had begun for less random and more predictable results. One improvement was to stack the pots on top of the fuel and cover them up to keep in the heat. It's a method still used in many parts of the world, as here in Rajasthan, in northern India. This led on to a solution which has lasted now for millennia. The appreciation that a permanent cover meant better control of heat brought the pottery kiln into existence. With the evolution of the closed pottery kiln, with its natural draft and thick heat-retaining walls, temperatures in excess of 1,000 degrees Celsius could be kept up for hours. In the enclosed space, the smoke and carbon monoxide fumes from the fire created a reducing atmosphere. Two of the conditions necessary for the smelting of metals were present. And so, on occasion, was the third, the metallic ores themselves. The proposition that metal smelting was an accidental discovery in the potter's kiln is based upon an accepted fact that very early in the history of pottery making, and at about the same time as smelted metals first appear in the archaeological record, the potters were using metallic ores to paint colored patterns on their pots. These potters are working at Jaipur in Rajasthan. A good deal of Indian life in towns and villages is still in this pre-industrial state. And while these men have a successful modern business, they're using methods and a kiln design which are known to be many centuries old. Pigments are still made by grinding colored ores, just as the peoples of prehistory made their body paints. The glaze is made by crushing a mixture of borax, broken glass, and lead oxide. The final coat of glaze, when it's fired, protects the painted design. So overall, and in its essentials, this is a picture which can have changed very little in perhaps thousands of years. With the help of it, we may plausibly imagine a time far back in history's mists, when the potters would not have been painting in this kind of detail, but something perhaps more rudimentary, like the body painting of tribal custom, bolder smears and wipes of metallic ores, perhaps. But then, as now, they were using a number of metallic ores in decoration. This pot hasn't received its white glaze yet, but on it you can see the bright yellow of antimony, the green of chromium, the blue of copper, the rusty red of iron, and the white of lead. In the long hours of firing, the metallic ores gradually take on their final colors. And when the heat is at its maximum and the kiln is filled with carbon fumes, so, it is suggested, the conditions for the smelting or reduction of the metals from their ores may have been met. There can't be any certainty, of course, that this was how the smelting process first came to be understood or followed. But the widespread, repetitive processes that pottery involves, the incubation of metallic ores in the enclosed heat of the kiln, makes it an obviously attractive possibility. The reduction of lead into globules like these after pottery glaze is fired here is a frequent occurrence. After that, it's only a short step to imagine those inevitable accidents and coincidences of especially favorable circumstances inside the kilns, which would have revealed to the potter the unexplained presence of something which hadn't been there before the firing, granules perhaps of metal, which would have led him on to try and reproduce, if not solve, the mystery. Once he did that, it would have been shown to him that the kiln itself was not the ideal place for the purpose. Only parts of it have a reducing atmosphere, and the heat is unevenly distributed. One can suppose that by the 4th or 5th millennium BC, the imaginary forces within people were sufficiently aroused for them to begin experimenting, trying to find all kinds of different ways of applying heat more directly to metallic ores. They gave themselves up more intensely to the endless seduction which has been exercised over men by those gleaming substances they knew existed within many of the rocks around them. The earliest indisputable evidence of smelting yet discovered anywhere in the world has been found here in the arid wilderness of the Sinai Desert in southern Israel. In 1960, an archaeologist, Benno Rottenberg, was exploring the dry wadis of the Timna Valley near the Gulf of Aqaba. This is one of the historic bridges of the ancient world on the pathway between Africa and Asia. At the foot of a hill, Rottenberg found the ruins of a very early habitation. Nearby were stone tools, apparently used for crushing copper ore for smelting. There were no obvious signs of smelting near the ruins, but Rottenberg looked on top of the hill, where the wind would help to raise the heat of any furnace fire. Here he found the evidence: scattered lumps of smelting waste or slag. Some contained small prills or blobs of copper. And with the slag were flint tools of the Neolithic miners. It was enough to bring a team of archaeologists here. What slowly emerged from the stony ground out here in the wilderness of God in the Sinai was this bowl-shaped furnace, built up with large stones. When the archaeometallurgists dug down to the floor of the furnace, they found the ashes of the ancient fires which had burned in it. And those ashes have been carbon dated to the 4th millennium BC. This simple, almost childishly simple, arrangement of stones is the location of a tremendous achievement. It marks the earliest place yet identified where man, without any knowledge of physics or chemistry, but armed only with that most distinctive of human attributes, his curious intelligence, first set out deliberately to smelt copper from the living rock. The metalsmiths were still not very good at the job. But this historic site at Timna confirms that by the 4th millennium BC, man had advanced from gathering native metals to smelting. Other finds from this region show that the techniques of metal casting had already reached a remarkable level of sophistication. In the early 1960s, an Israeli expedition began exploring caves along the rock cliffs facing the Dead Sea. One of those caves was barely accessible, but in it they found, undisturbed, the signs of human usage dating back to the 4th millennium BC. Inside was a hoard of strange metal objects, thrust into a crevice, wrapped in cloth, perhaps hastily hidden. This find from what they called the Cave of the Treasure is now on display in the National Museum in Jerusalem. It contains more than 200 artifacts, fashioned from copper, with consummate skill. The objects and their cloth wrapping have been firmly dated to at least 3000 BC. Nothing like them from this period is known from anywhere else in the ancient world. There's no clue to who might have made these highly polished shapes or where they came from, and their precise function remains a mystery. But the power and assurance of their forms speak for a growing mastery over metals at a time when stone was still in general use alongside copper. When archaeological exploration of the southern Sinai was extended into the eroded valleys around Timna, it established a chronology of mining and smelting that extends right down through the past 6,000 years. Here, preserved by aridity and isolation, is the most detailed record of the earliest mining for metal available to us anywhere in the world. The prize was malachite, a copper ore that occurs here as nodules in the soft sandstone. By the 2nd millennium BC, these activities had greatly expanded as the pharaohs of Egypt colonized all Palestine. The Egyptians recruited their miners from the biblical tribes of Midian. The Midianites left the imprint of their ancient labors on the shafts and drives. Here they dug out the wealth which helped to sustain the pharaohs of the new kingdom. The scale of these Egyptian smelting operations is suitably impressive. Hundreds of people worked at scores of furnaces here. The London Institute of Archaeometallurgical Studies is investigating Egyptian technique on these ancient sites, recreating in the Sinai Desert copper smelting as it must have been carried out under the pharaohs 4,000 years ago. The furnace itself is made from local clay, identical to those found here, packed around with stones and sand. These, then, were the techniques which, it is proved, kept the temperature inside the pharaoh's furnaces close to 1100 degrees for hours on end. The application of forced draft to smelting was a crucial advance in the endless search for more heat, more energy that persisted through the history of metals.
And the other stuff?
Everything's all mixed together. 3 kilograms of hematite to 1 kilogram of copper ore. It's all mixed.
After 6 hours firing, there's a good depth of molten metal. The furnace can now be tapped to run off the lighter slag and leave the heavier copper metal in the furnace base. The amount of copper won will not be known until the furnace cools down overnight and can be opened up. In this instance, the copper has failed to separate from the slag. But the smelt, while falling far short of the known competence of the ancient Egyptians, has achieved enough to prove the process works. At Luxor, on the Upper Nile, the grandeur of the ruins speaks for the power and scale of the Egyptian Empire. In a village near the Valley of the Kings, an extraordinary account survives of daily life in the New Kingdom in the 2nd millennium BC, when the Egyptian Empire extended as far as Libya, Palestine, and Syria. Beneath the hillside lies the tomb of Rekhmir, a Lord Chamberlain under the pharaohs of the 18th dynasty. The crowded scenes on the walls are a documentary of Rekhmir's times and of his responsibilities. One scene shows in detail the casting of a pair of large temple doors. Metal arrives in 2 forms: baskets of small ingots and a large flat slab of copper shaped to make it easier to carry on the shoulder. 2 sets of bellows raise the furnace temperature to the melting point of copper, more than 1,000 degrees Celsius. The crucible of molten metal is lifted with newly cut poles. The sap prevents them from catching fire just long enough for the copper to be poured into the mould. The Rekmir tomb painting, fresh and clear after 3,500 years, is one of the earliest and most explicit records we have of metal casting. It confirms that by the 2nd millennium BC, the technology of handling copper on a large scale was well advanced. There are good reasons why copper became the first metal to be widely used and steadily replaced clay and other natural materials. Copper ores were often on or close to the surface of the earth. The smelting of these ores was not particularly complicated, and good quality copper could be made consistently. Markets across the ancient world were flooded with copper utensils of all kinds. But when it came to tools and weapons, copper's softness was a disadvantage. Observation and experiment produced a huge advance. It was an observable fact that copper smelted from ores containing traces of arsenic or other elements was much harder than pure copper. A blend of copper and tin was found to yield a metal which was easy to cast, extremely hard, yet which could still be worked by hammering. This alloy was to give its name to the first great period of metal working, the Bronze Age. The durability of bronze produced superior tools and weapons, which went hand in hand with the rise of empires. It yielded not only power, but also aesthetic pleasure. By 2000 BC, most parts of the Middle East were living in the Age of Bronze, as was the island of Cyprus. Cyprus lies across the sea routes of the eastern Mediterranean. That alone was not enough to give it its brilliant place in the Bronze Age. The fame of Cyprus arose out of its vast resources of copper. The scale of the Bronze Age metal industry on Cyprus has been revealed by excavations like the ancient city of Kition, which lies buried beneath the suburbs of the modern coastal township of Larnaca. Beside the great temples and palaces, there was a flourishing industry in copper smelting and bronze casting. Cyprus and this place help to focus an intriguing mystery about Bronze Age metallurgy. The name itself, Cyprus, has had the meaning of copper for some 2,000 years. There was always plenty of copper on the island. It's been mined here for millennia. But there was no tin on Cyprus for making bronze. and there is no other source of tin anywhere else in the Mediterranean close at hand. And so a long, distant tin source seems very likely and indeed a necessity. But it's never been identified, although Cornwall, Iran and Afghanistan have merits as candidates. But the underlying issue, which the metallurgist has yet to resolve, is this. How was it, if there was no tin in the Mediterranean, that the earliest metal smelters discovered the ideal properties of tin as an alloy of copper in making bronze? It would seem logical to suggest that tin bronze may have been discovered, perhaps inadvertently, in some part of the world where tin and copper are found together. But there are very few places on Earth where that occurs, and in none of them has there been found any evidence of early Bronze Age metallurgy, until recently. And here is an instance where the revelations of recent years have mounted such an attack upon the established view of the ancient world. Southeast Asia has a long history of civilization, but as far as technology is concerned, this part of the world has been thought of as a backwater. The region is rich in copper and tin, but there was no evidence here of any use of them. This view has been challenged only in the past 20 years as a result of discoveries made in northern Thailand, and particularly in this village, Ban Chang. Ban Chang lies close to the border of Laos and to Vientiane, its capital. The inhabitants of Ban Chang migrated here from Laos some 200 years ago. They cleared the light bush and settled down to a rural subsistence. Then in 1966, an American student working on a road construction project near the village found some unusual pots in a freshly dug cutting. When these found their way back to the United States, together with bits of corroded metal dug up nearby, they aroused intense curiosity. Preliminary tests gave dates which seemed impossibly early for this part of the world, especially for the metal objects. The outcome was that in 1974 and 75, a joint excavation was mounted at Ban Chang by the Thai Fine Arts Department and the University of Pennsylvania Museum. The team made discoveries which have shaken not only the accepted chronology of prehistory in Southeast Asia, but many long-held beliefs of cultural development in general. What they found here was a record of previous occupation of the Ban Chang site, starting before 3000 BC and ending about 250 BC. These broad dates have been established by carbon dating of organic materials and thermoluminescence tests of the pottery. The 18 tons of artifacts recovered, mainly burial furnishings, are being studied in a number of laboratories around the world. The most intriguing finds, because of their dates, are the metal pieces now under examination in Philadelphia. The earliest is this cast bronze spearhead from about 2000 years BC, found in the lowest levels. The archaeologists were even more startled by this spearhead. A bronze socket has been cast onto a wrought iron blade. It's been given a provisional date at the end of the second millennium BC. And this is an extraordinarily early date for such a sophisticated technology. The evidence that these objects were made locally and not imported includes a number of crucibles with traces of bronze still adhering to the lining. If the dates for the various levels of this excavation stand up to a final, exacting scrutiny, they will place the hitherto unknown and unsuspected metalsmiths of northern Thailand on a par with the most advanced metal workers anywhere in the ancient world. The result, if not the purpose, of this excavation, providing the dates come to be more widely accepted, will be simply iconoclastic. It has been a long-established tradition of scholarship which has designated Mesopotamia and the valleys of the great rivers, the Tigris and the Euphrates, as marking the beginning of civilized advance on Earth, the art of writing, the first towns and cities, the making of bronze. And that civilized culture then spread out and was diffused elsewhere on Earth. Banchang is something of a lightning flash across the archaeological world, illuminating an academic war between those who continue to hold that civilized culture did spread out and was diffused from that original cradle in Asia Minor, and those who argue, as they do here, for a local, independent evolution and invention. As one of the Americans who was involved here put it, what we found here at Banchang was like finding hubcaps under the ruins of ancient Rome. Whatever the final verdict on the dates of the Banchang bronzes, there's already ample proof of the existence here of a technically innovative people who by the 4th or 3rd millennium BC were quite capable of using the local deposits of both copper and tin to take their first steps into the Bronze Age, as early here perhaps as anywhere. There is, of course, already a massive body of evidence for an independent discovery of bronze in the East. It's to be found in the vast land to the north of Thailand. Underneath these fields at Anyang in the Hunan province of China, an ancient city lies buried. 1,400 years BC, an emperor of the Shang people, Pan Ken, moved his capital to what is now this cultivated land. And here the Shang dynasty flourished on this uniquely formed and fertile land made up of vast drifts, sometimes several hundred feet deep, of yellow, wind-blown dust, dust called the loess. The people of Anyang in those times lived an existence not unlike that still to be seen here. But specialists among them also found time to create some of the most technically accomplished works of art in metal ever known. The things they made were buried as ritual gifts. Over the centuries, as the graves were discovered and looted, these objects found their way into museums and collections all over the world, and the Shang bronzes took their place among the great artistic triumphs of early civilization. In 1956, the archaeologists resurrected the ancient city. A systematic, scientific excavation brought to light even more exquisite examples of an ancient art which had been looted down the years and which had made the Shang dynasty famous. And after they had dug it out, the archaeologists reburied the old city in the loess and returned the land to cultivation. The result is that China's own museums, like the one at Anyang, are beginning to augment the record of an unrivaled flowering of creative expression. The most immediate characteristic of Shang bronze work is its skill in casting. Chinese craftsmen made little use of Western techniques of shaping or finishing by hammering. They were masters of molten metal, and their aim was to cast each piece complete in every detail. The Shang bronze tradition would seem to have grown out of the art of the potter, particularly his skill in preparing molds and his advanced kiln designs with their higher temperatures. The continuity and tradition from pottery to bronze is clearly apparent in the remarkable similarity of forms. The pottery vessels beginning around 5000 BC are followed by their Shang bronze derivatives 3,000 years later. This is the evidence which is held to support the case for an independent local development of metallurgy in China. An achievement that would surely have been within the reach of a people who were close to inventing gunpowder, paper and printing, clockwork and the compass. What is beyond dispute is that by the second millennium BC, Shang craftsmen were using molten metal with an artistic, technical assurance that was rarely, if ever, approached elsewhere in the ancient world, east or west. The most powerful statement of that skill is now part of the national collection in the vaults of the museum in Peking. This huge bronze cauldron was an accidental discovery. It was found by peasants digging in those fields at Anyang in 1939, and it was used by them for some time as a store for pig food. Something like this is in a different category of bronze altogether. Exquisite is plainly too perfumed a description for something as muscular, stolid, and ponderous as this is. But in technical terms alone, it represents an extraordinary accomplishment. The massive body of this vessel was cast in a single piece, and it remains the largest single casting in metal anywhere, which can be dated with positive assurance to the second millennium BC. It's 1 1/3 meters high, just over 4 feet, and it rests those inches weightily. It's 875 kilograms, about 2,000 pounds, and it weighs, therefore, just under a ton. And so this confronts us with its presence. Modern metallurgists have wondered how it could have been possible 4,000 years ago for the Chinese to have poured a ton of molten metal to make this, although the crucibles have been found which could have supported the heat and weight of a molten mass like that. But it argues that 4,000 years ago in China, there was a metal technology which was no mere aggregate of village smithy fires, but which approached the scale of an industry. This was bronze and the Bronze Age at its lofty zenith. But man's preoccupation with bronze was about to be violently interrupted. In consequence, he would knock at another, more formidable door and enter the Age of Iron.
I'm Robert Raymond, and I'm the producer of this series. One of the major unanswered questions in the history of man's use of metals, which we raised in the episode you've just seen, concerns the source of the tin which made the Bronze Age possible. Now, bronze consists of copper with about 10% tin, but there's no known source of tin in the ancient world which could have explained the huge production of objects like those to be seen here in the University of Pennsylvania Museum in Philadelphia. Artifacts made in Cyprus, Egypt, Mesopotamia and Assyria in the 3rd millennium BC. The problem continues to puzzle archaeologists and metallurgists, including the man who's probably investigated this mystery more than anyone else, James Muley, Professor of Ancient History at the University of Pennsylvania.
Whether they contained inscriptions. We have been looking for possible sources of this tin throughout the entire area.
Whereabouts have you looked?
Oh, we've looked everywhere, from Greece through Iran and Afghanistan. In looking for possible sources of tin, one thing we can say is that tin almost always appears in a host granite rock. The tin is to be found as inclusions in quartz veins that run through the granite rock. I just happen to have some examples here with me. These are some pieces that we collected in the eastern desert of Egypt back in 1976. This is the way the inclusion of an oxide of tin called cassiterite appears in nature. It's washed out of the quartz eventually by the action of the water and collects small nuggets of cassiterite in the bed of the stream. So this is what you are looking for as a possible source of Bronze Age tin. But no one has ever been able to find any real geological evidence for tin in the area. We've never been able to collect any actual pebbles of cassiterite.
So what's your thinking now then about the whole problem?
Well, our best geological evidence at the present is for the presence of tin here in Afghanistan. In the 1970s, a group of Soviet geologists working on behalf of UNESCO found a number of deposits of tin in Afghanistan, sizable deposits that really could represent an ancient source of alluvial tin or cassiterite. This makes very good sense from an archaeological and historical point of view as well. We know that the ancient Sumerians used a great deal of lapis lazuli, a semi-precious blue stone that is found only in mines here in northeastern Afghanistan.
So Afghanistan would fit the picture?
So Afghanistan would fit everything we know about the archaeology, about the geology, and about the general historical situation in the 3rd millennium BC. Now, obviously, if you have a geologically attested source of tin, then the thing to do is to go to those sources to see if you can find evidence for ancient working. Can we show that these deposits were really being exploited in the 3rd millennium BC? Unfortunately, right at the time when this geological information became available, the Soviet invasion of Afghanistan closed down the country to any further archaeological investigation. So we are left at present with a possible source of tin that makes very good sense in all archaeological and historical and geological terms, but no way of really investigating this source to see if we can prove that it really was being exploited in ancient times.
As we suggested, the discovery in the 1960s of a Bronze Age culture at Ban Chang in Thailand, this is some of the pottery from the excavation, has challenged many established theories of cultural diffusion. Support for the idea of an independent metalworking tradition in Southeast Asia comes from an important new discovery in that region by Dr. Vincent Piggott of the University of Pennsylvania Museum.
What we were able to discover in the time on survey, thanks to the work of a local Thai geologist who had been surveying there for approximately 20 years, was a prehistoric copper mining site located right here on the banks of the Mekong on the Thai-Laotian border, where sometime in the mid-1st millennium BC, Thai peoples were extracting copper-based minerals from a surface deposit, primarily malachite and native copper. We have some indication of metal processing, including pieces of molds. Here you have one half of a bivalve sandstone mold for the making of a socketed copper axe, and in fact, from one of the excavation locales, a socketed axe of as yet undetermined composition, but in Thailand, most prehistoric copper-based artifacts are made from copper and tin, that is bronze. So this can lead us then into the whole question of how metallurgy was evolving in Southeast Asia, which brings on the larger question of the idea of cultural diffusion of technology as opposed to localized, indigenous, independent invention. I think at the moment the evidence does not come down in favor of either argument very strongly. Certainly in Thailand, all of the basic necessities for the origin and development of metallurgy were in place by the late 3rd millennium BC. On the other hand, it's quite true that metallurgy had evolved significantly earlier elsewhere in the Old World, particularly in the Middle East, than it had in Southeast Asia. But what's important about the research in Thailand and Southeast Asia today is that we are looking at these problems really for the first time in the field via the techniques of archaeology and scientific analysis. And we stand a very good chance of bringing to light an answer to this question as the research proceeds.
Out of the Fiery Furnace is brought to you by a company that makes aluminum for transportation, construction, and manufacturers of consumer products all around your house. Commonwealth Aluminum.
The companion book, Out of the Fiery Furnace, by Robert Raymond, is published by the Penn State Press and is available at bookstores throughout the country.